This lesson is for FST, Lesson 4.4 on exact values for sine, cosine, and tangent. We're going to start by doing a quick review of converting degrees to radians. Students need to be comfortable with that by this point. So we're just going to focus in on the first three values in quadrant 1 of the unit circle and converting those to radians just for practice. So this doesn't have to do with exact values, this is just simple review. Remember that to convert degrees to radians, you'd multiply by pi over 180. And the reason why I put the pi on top is because I want radians. You could also multiply by 2 pi over 360, but the 2 and the 360 would reduce to 1 and 180 anyway. So when we put those two fractions together by sticking a 1 under the 30, multiply straight across, you get 30 pi over 180. Again, some rules for reducing. If you are working with two numbers that end in 0, that means 10 is a common factor. So we can simply cross out the zeros. 3 is a common factor with 18. 3 goes into itself one time, 3 goes into 18 6 times. So we end up with 1 pi, or just pi, over 6. So 30 degrees, hopefully students could convert that easily into radians by saying pi over 6. Similarly, if we're converting 45 degrees into radians, we would simply multiply by pi over 180. If you multiply by pi over 180, you just get 45 pi over 180. For reducing here, both of these numbers end in a 5 or a 0, so that means 5 is a common factor. 5 goes into 45 9 times, and 5 goes into 180 36 times. So now I'm left with 9 pi over 36. So clearly I did not pick the highest common denominator, or excuse me, the highest common factor here because I have another common factor that has shown up. 9 is a common factor of both of these numbers. 9 goes into itself once, and 9 goes into 36 4 times. So this reduces, in fact, to pi over 4. On the last one here, if I've got 60 degrees that I want to convert to radians, I'd multiply by pi over 180. When I do that, I just get 60 pi over 180. Again, I'm back to canceling out zeros because there's a 0 on the end of both numbers. So I'm dividing both numbers by 10. 6 is a common factor now. 6 goes into itself once. 6 goes into 18 3 times. So I end up with pi over 3. So that was a quick review for students on converting degrees to radians. Our focus for today is on exact value origins. And these exact value origins come from 30, 60, 90 triangles, as well as the 45, 45, 90 triangles. These are triangles you would have studied back in geometry, and in those triangles there are some relationships that exist, and those relationships have been given here as one of the legs is a 1, the other leg is square root of 3, and the hypotenuse is a 2. So that's true for every 30, 60, 90 triangle. Similarly, for a 45, 45, 90 triangle, the legs would each be 1 and the hypotenuse would be square root of 2. So these are geometry review items that we're not going to get into much detail about. What we need to do to use these triangles for the unit circle is to convert them so that the hypotenuse of each triangle is a 1. Remember that our unit circle has a radius of 1, and so this hypotenuse length needs to be converted to a 1 so that we can superimpose this triangle onto the unit circle itself. So if we need to convert that 2 to a 1, we would simply divide everything here by a 2. So when we do that, we get a 1 for the hypotenuse, a half for the vertical leg, and square root of 3 over 2 for the horizontal leg. So we're going to put that on the unit circle here momentarily. Similarly, for the 45, 45, 90 triangle, if we try to get this hypotenuse to become a 1, we would need to divide by square root of 2. If we do that to the hypotenuse, we would have to do it to the legs as well. So when we do that, we get a 1. Over here we get 1 over the square root of 2. Can't have a square root on the bottom of a fraction, so we would multiply by the square root of 2 on the top and the bottom, which simplifies to square root of 2 over 2 for both legs. So now let's peek at our unit circle. We're going to put the 30-degree angle in and show that the y value is a half and the x value is square root of 3 over 2. So let's go to our unit circle next. At 30 degrees, the cosine is the square root of 3 over 2 because that's the horizontal component. The y value is the vertical component, so that'll be 1/2. Flip-flop those, because when you take your triangle and rotate it so that now the 60 is the angle that you're working with, now this becomes your x value and this becomes your y. So if we go back to our unit circle, the y value, or excuse me, the coordinate at 60 degrees is the same values, just in reverse. For the 45, 45, 90 triangle, we've got square root of 2 over 2 for both the x and the y component. Those values then translate or rotate into all the other quadrants. If you take these values and now flip them over the y-axis, you get your values in quadrant 2, and they are indeed the same values as each other, shown here in color. All the green ones are the same, all the light blue ones are the same, and all the purple ones are the same. The only difference is now that we're in quadrant 2, remember that the cosines are all going to be negative. Now if we flip all of these values over the x-axis, we'll have all the values we need in quadrants 3 and 4. So again, all the purple values are the same, all the green values are the same as each other, and all the blue ones are the same as each other. Now that we're in quadrant 3, everything turns to its opposite. And in quadrant 4, remember that the cosines will be positive, but the y's will be negative. So really it's important for students to memorize the fact that in quadrant 1, the first value is going to be square root of 3 over 2 for x, or for cosine, and 1 over 2 for y, or for sine. The 60-degree angle has those same values in reverse, and the middle value in quadrant 1 is going to be square root of 2 over 2 for both cosine and sine. So students should take the time to finish memorizing the unit circle, and those are going to be the questions they're going to be asked on the oral unit circle quiz. So let's go back to the notes. We have one more thing to talk about, or a few more things to practice, then we're going to talk about tangent. So for example, on the unit circle quiz that students will be doing next week, the cosine of 120, think about where that 120 is located. It's the first click into quadrant 2. That's going to be the same as doing the cosine of 60. Cosine is the x value. Since we're in quadrant 2, we know it's going to be negative. It's going to be the same as doing the x value at 60, so that should be a negative 1/2. If we jump down and do cosine of 150, remember that that's still going to be a negative value because it's an x value, but now it's going to match with the 30-degree angle, so that's going to be square root of 3 over 2. On the next one, cosine of pi over 4, you won't have any radian values on your oral unit circle quiz, but that is something that you're going to need to know how to do. I know from my earlier practice today that pi over 4 is the same as 45, and I know that whenever I have a 45, that's a value that ends in 5. I'm in quadrant 1, so it's going to be a positive value. I know that that's always going to be square root of 2 over 2. Now let's practice with some sine values. If I do sine of negative 30, and that should say negative 30 degrees, I know that that's the same as doing the sine of 330 degrees. Those are in the same location. So I know that I'm in quadrant 4. The sine is going to be the y value, so that y value is going to be a negative, and it's going to match with the sine at 30 degrees, which I know is a half. 2 pi over 3 I don't have memorized in radians, so I'm going to do a quick conversion to that into degrees. So I'm going to multiply by 180 over pi. The pi's are going to cancel. I can reduce the 3 and the 180. 3 goes into itself once, goes into 180 60 times. So I know that I'm really doing the sine of 120 degrees. So I know it's going to be similar to what I had back here for cosine of 120. I know that the sine in quadrant 2 is going to be a positive value, and I know it's going to be not a half because that was the cosine, so I know it's going to be square root of 3 over 2. Last one we're going to do here for practice is sine of negative 180. Negative 180 is the same as positive 180, and I know that the y value there is a 0. Notice how I did not use or verify with my unit circle at all. I simply did all of these from memory from what I know of quadrant 1 of the unit circle. Last thing we're going to do here in the video is tangent practice. Students need to know the tangents of these three. If students know these three, then they'll be able to tell any other value on the unit circle as it relates to tangent. Students will not be quizzed on this in the oral unit circle quiz. There will be no tangents in the oral quiz. So let's go ahead and do tangent of pi over 6. Quick reminder that pi over 6 is the same as 30 degrees. So we're doing the tan of 30 degrees. Quick reminder that for tangent, you're doing sine over cosine. So I need to remember what the sine and the cosine is at 30 degrees. I know that the cosine is square root of 3 over 2, and the sine is 1/2. If I'm dividing fractions, all I need to do is take the top fraction and multiply by the reciprocal of the bottom. When you multiply across here, the 2's will cancel, leaving us with 1 over the square root of 3. Unfortunately, you can't leave the square root of 3 on the bottom of a fraction, so we're going to multiply by that on the top and the bottom. When you multiply straight across, the square root of 3 is on top, and the square root of 3 times itself. The square roots here will cancel, leaving you just a 3. So when you do the tangent of 30 degrees or the tan of pi over 6 radians, you get square root of 3 over 3. Notice that this does not have a 2 on the bottom like it would on the unit circle. So when you're doing sine or cosine, you'll have square root of 3 over 2 as your answers. When you're doing tangents, you'll have square root of 3 over 3. Let's go ahead and do pi over 4 next. And hopefully you remember that pi over 4 is the same as tangent of 45 degrees. Remember that when you're doing sine over cosine, those end up being the same when you're at a 45. Square root of 2 over 2 divided by itself. I shouldn't even really need to write that out because I know when I divide something by itself, I get a 1. So anytime you're working with a 5, or a number that ends in 5 when you're working with degrees on the unit circle, the tangent of that is always going to be a 1. Keep in mind that when you're in quadrants 2 or 4, however, the tangent will be a -1 because one of these will be positive and one of them will be negative. So if you do a tangent of a number in quadrants 2 or 4, make sure you make your values negative. The last one we're going to do is the tangent of pi over 3. And pi over 3 is the same as doing the tan of 60. So it's going to be the reciprocal of what we did when we did the tan of 30. So there's two ways we could handle that. We know that it's going to be the square root of 3 over 2 divided by 1/2, which when you simplify that is going to be the square root of 3 over 2 times 2 over 1, the reciprocal of the bottom. 2's cancel and we get square root of 3. Could also take the reciprocal of the answer that we got for 30. So we could just take 3 over the square root of 3. Can't have the square root on the bottom, so you would multiply by the square root of 3 over 3 on the top and the bottom. On the top here you'll get 3 times the square root of 3. On the bottom the square roots will cancel, giving you just a 3, and those 3's will cancel as well. So when you're working with tangent, know that you're going to get square root of 3 over 3, or just square root of 3, or a 1 for your answer.